Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Part 9. Moving objects. That's what we're doing. I'm gonna first show you what we're aiming for. Let's have a look. The player's still moving. I can move that thing around. Gravity working still. Jumping. I've kind of fixed the jumping bug. See, in an elegant way. The thing is that the index 0 of the jump table just isn't, well, it's being used to detect whether or not the player is jumping at all. So the first position is being used, so I've sort of shifted the numbers right one section, and then it does the full jump. So I'm guessing that in some future version that bug will iron itself out. But in the last episode, we had the objects standing there, and now they're moving. And as you can see that they are being blocked like the user is. It's just gravity isn't working on them, but they are moving just as the user was moving. Just one is going left and right, one is going up and down. Now we would like, of course, to not have to rewrite the code for each object, and also, we'd like to have the same code for each object, and just differentiate by enemy behavior. And we've done that, and boy, how have we done that? That's I'm impressed again with the way this is solved. And instead of looking at the data first, I'm going to look at the game loop. We now have, instead of user control or player control, we now have object control. So we're aiming for viewing the player and the enemies as objects and controlling them using the same code. Now, this goes back to setting up the code in the first place, and it sort of determines how we can use it now. So there's actually been a lot of thought in, gone a lot of thought into creating that code, or we're just going with the flow and we made lucky choices. It's sort of a design kind of ethic there. So object control, there's a new function, object control, and let's have a look at it. And here we go. Object control. The X is an index into the active sprite table. In the last episode, I sort of closed with saying that the sprite active table is filled with sprite pointers, but it isn't. It's filled with object type. An object type can be player, or it can be a type of enemy. So the X is 0 is in this table the first sprite, which is always the player. Basically what we do, we check if it's active. If it's not, we go to the next object, which basically just increases X until it reaches the length of that table. We still use a fixed number here, which is probably all right, but other functions use a constant here, and this is just an immediate value, whatever it is, a tiny thing. Anyway, if we're at the end of the table, then we exit out of this routine, and otherwise we go to the next object. So, and now here's the thing: the y is loaded with the value that is there, and that is the type. Now, the type actually matches the index +1. So if the sprite type is 1, that means that we're looking at the player, which is 0. So we decrease that value by 1. That's just sort of an unlucky coincidence that it works that way. But to get to the correct location in this new table here, we need to have the sprite number. So we decrease it. Now, this function sets up the call. What we want to do, instead of testing for the object type and then calling a function that is, that matches that type, we basically do this. We do one jump to a function, and we use 0 page pointer 2. We do a jump to a function, and we set up the correct function here. This enemy behavior table actually has the addresses to the functions that match a certain object type. Yeah, so it loads that into 0 page pointer 2, and it does something here that I'll talk about next, and then it calls that function. So we've basically translated the object type into an address of a routine that describes its behavior, and we call that, and then we take the next object. Now, looking a little bit closer at this code, all the functions that we've written so far, because this goes for the player as well, right? So we're no longer physically calling player control. If you look down here, the print is small, but it says unused label player control. And not down pressed, but we knew that already from the last time because gravity took over this one. But player control isn't being physically called by our code anymore, but it is because we do this call, and this calls player control, and it also calls the object control. So in each iteration of this loop, we call a piece of behavior code that matches the object type. This is really smart. This is really nice. But we have a problem because we do a jump. What we would like to do is do a JSR here. So we'd like to call a subroutine here. The only problem is that in the 6510 jump subroutine doesn't have an indirect addressing mode. It only has absolute. So jump does have an indirect addressing mode, which we use here. But the problem is that at the end of these subroutines that we're calling is a return from subroutine, an RTS. And what RTS does is it takes the I should start from the beginning. What happens when you do a jump subroutine is that the 6510, the CPU, writes the address of the next instruction onto the stack. In basic, generally speaking, it writes a return address on the stack, and RTS, at the end of your subroutine, you do an RTS. What that does, it pulls that address off the stack and puts it in the instruction pointer. So you're basically back at the instruction where you were going. But there is one thing that the 6510 does, is that it not only does a JSR write the the address of the next instruction onto the stack, but it subtracts 1. And it doesn't really make sense because RTS at the end of the subroutine, takes that instruction back off the stack and adds one. Now, my guess is that that mechanic was introduced by the designers of the chip to differentiate between interrupt calls and subroutine calls. But whatever the reason, we have to take that into account, because what we do here, since we know we're going to do a jump to a subroutine, when we RTS out of those behavior subroutines, we want to end up at this instruction. But an RTS without a JSR isn't really going to work. So we set it up here. Basically, what we do is that we load the address of... Oh, I should scroll left. This address, next object -1, which is what RTS expects, and we push that on the stack, and we do the same thing for the low part. So the high part and the low part, of course, they go in reverse order. We push those onto the stack, then we jump to the routine. At the end of that routine is an RTS, which will take this address and jump there, and it continues. So basically, we've programmed the mechanism to match object type to a behavior routine, and it's being called here as if it were a subroutine, but we use jump because this is a relative addressing mode, or an indirect addressing mode, I should call it. And that's the object loop. Now, let's look at the data. I'm scrolling down. Let's look at the data, because we've had a couple of additions here. First of all, there's a sprite direction. There are sprites going to be going left and right and up and down, and these are basically toggles to say, we're either going one way or the other, and we have to reverse at some point. So, like an automation of sprites, but these are just dumb enemies. They only go left or right, and they only go up or down. So this is a simple solution still. I am very curious as to what the more intelligent enemy behavior is going to look like. The AI, that's going to be more complex than this. And here are the tables. Of course, the addresses are split into low and high, which is self-explanatory almost. But the table is indexed by object type. So the first type is player control, and here we see the problem, of course, that the player type is 1. We'll see that in a minute, and the 2 player enemy types, 1 left and right enemy type and 1 up and down enemy type. And we put the addresses here. Type 1 is index 0. Type 2 is index 1. Type 3 is index 2. So that's why we have to decrease the Y. We have to translate from one to the other. Table high, table low. So this is the table of addresses. And if we scroll up, you go past all the constants, and here are the enemy types. Player type 1, left, right enemy, up, down enemy, 1, 2, 3. There we go. Objects, we had that in the last episode. So let's look at how this controls, because in the main loop, we had object control called, so I'm jumping to object control, and here we are. This is the call that we had. So let's look at a behavior dumb enemy left right. We've picked that up from the sprite active thing. We know what kind of type it is. So we're only moving active objects here. Yeah. At some point when we are using inanimate objects, we will have to do something there. But we're only handling objects that are active. We call their behavior method. Basically, we just determine its direction. We look in the sprite direction table for the X index. This indexes the sprite number. It doesn't say that here, but it's almost implicit. But it's a very important thing in assembly programming to realize that the X register, which is of course a super global variable, well, we have to realize that is at this moment the sprite number. So we get its direction. If it's 0, then we say move right. So we jump to the move right code, and then we toggle the direction. Otherwise, we move left and we toggle the direction. And the toggle direction is get the value from the table, exclusive OR it with 1. So it starts off as 0. And an exclusive OR is always like a ones complement. We flip the bit around, so it's either 1 or 0. So that's a very basic code here. And move object right. If we look at these functions, object move right, it is basically just the player move right code, but with two changes. First of all, player move right is nothing more than the object move right, but with the index, the sprite index set to 0. So if we call player move right, we get this. Right? We set X to 0. Now, subroutines that change a global variable are dangerous. We have to realize that we call player move right, and we're in a loop where we use X as an index. X is being reset to 0 here, so we have to remember that. And also remember that this code is being called once every game loop, but that the movement code was written like that, so we can just use it. I mean, that's very powerful. We've thought about that. We've programmed it the correct way, and now it's easy to make objects move using the same code. We're basically reusing code that we've already written. But as I predicted in the previous versions of the code, these tables were not being indexed, because they were only meant for the player, meant that not using X as the index gives you the first index into the table, which was the player value, and as long as this code is for the player, there's no problem. But now it's for every object, so we have to add all these indexes into those tables. So that's been done here. The code is all the same. We still check for blocking, and we do all the things that we did before, but now it's for objects, and nothing's changed other than that. So let's see if I go back to object control, if I can find it. Object control here. Only the player control, because player control is still being called. If I go to player control, there we go. Go to player control. The player is the only one that is using the gravity thing, right? I mean, we're always calling player move down. If I go to player move down, there is an object move down, but it's not being used. So objects are currently not being affected by gravity, but they can, because the code has been modified to do that. But it's not happening. If we go back to the code, go back to the program here, this one is supposed to fall at this point, and this one is just moving up all the time, moving down and up. That's why it's going down, but not because of the gravity. So these aren't being affected yet, but the code is there. But this already looks more like a game. You know, it's now these guys are moving. Now we have to make sure that when we touch them, we get hurt. Okay. Well, it's 20 minutes. I expected this to take a lot longer, but that's really what this all boils down to. Object control, go back to object control. This I think is truly brilliant. Brilliant thinking to reuse the code like that and call those functions, put the addresses in a table. I might have done that differently, and I may have, painted myself into a corner had I done that, because you always have to think about how can I extend. It's now easy to extend object types and their behavior. I would have probably chosen a more direct path, testing object type and then physically calling a function that matches that type. But this is more, elegant. Again, the word elegant. So, well, I've enjoyed this one. We're about to reach part 10. I think there's going to be around 100 parts to this series, because there was 100 steps in Georg's original tutorial. But I know that there's a couple of steps there that not much happens. But we're around 10% of the entire series. And I'm still having fun, so I hope you are having fun as well. Any questions, remarks, comments, please feel free. Remember that the code is available from GitHub. There's also there's a file there with links to each individual step to the tutorial, so you can read Georg's comments. I don't use his comments in the videos, by the way. I do read them sometimes, but they are they're pretty short. It's the word I'm looking for. I can't find it, but the whole reason for me to making these videos is to elaborate on his comments. So, but you can check those out as well. And I will see you next time. Bye bye.